know we've all had a lot of days where we didn't think we would get here. Didn't know how we'd see our way through. In my mind, the risk is all in the other direction. The risk is staying at home. The risk is not trying. The risk is not moving humanity forward. Nobody has ever been closer to a Renaissance in supersonic flight than we have today. We got a lot of challenges ahead of us, but we got some challenges behind us too. Days like today are the ones that we're going to remember.
Mojave Air and Spaceport, automated weather observation, 192, Niner Zulu.
Here we go. This is for first flight. I need a positive receipt from everyone. FCS.
Go.
Dampers.
Go.
Aero.
Aero go.
Flutter. Flutter, go. Loads.
Loads go.
Avi.
Avi go.
Fuel. Fuel go. ECS.
Go.
Drop. Drop go. Electrical.
Electrical go.
Instro.
Instro go.
Test director. Go.
Hey guys, how about XB1? How about this team?
Good morning and welcome. My name is Mike Bannister. My mum always told me if you get a round of applause at the beginning, stop, because it's only going to get worse. Welcome to our news conference. It's great to see you all. Our species has always had two great aspirations over and above the natural ones of survival and food and water, and they are speed and travel. We've always wanted to travel faster. It's 5,500 years ago since we domesticated the horse to enable us to chase after our prey more quickly, to cover more hunting lands and to meet more people. Then we developed very slowly. We eventually got bigger ships, better ships, safer ships to go further and further around the world, but it was still horsepower that led to our speed until the 19th century when we invented the railway and the car. We could go faster. Early cars only had 4 horsepower engines. It wasn't until the early 20th century that we got onto aeroplanes, and we could invent aeroplanes that enabled us to travel faster still and go further. It was 105 years ago that the first scheduled airline in the world started. It flew an aircraft from London to Paris, a small aircraft with just 2 or 3 passengers. But it grew and grew and grew. And those aircraft became faster with bigger and bigger piston engines. But it wasn't until after the development of the jet engine that enabled us to go really quickly, to start doing things around the world, to start shaping the world as it is today. The jet age really made a big difference. Then in 1947, Chuck Yeager went supersonic, faster than the speed of sound, but only in a small rocket-powered airplane with just 1 seat for the pilot. It took visionaries to think of being able to make that possible just for you and I. So in 1962, the French and the British government got together and they signed a treaty between the two countries to build Concorde. It only took them 7 years before they had an airplane flying. And it's 50 years ago next month that the first 100 passengers were carried on Concorde at twice the speed of sound. 50 years ago. It's quite amazing how things have plateaued since then. Now, I always wanted to be a pilot from the age of 7, just this little dewy-eyed kid wanted to be a pilot, and I told mum and dad, and they said, yes, dear, but it happened. And when I got to British Airways, I thought this is the thing to do, and I saw that first flight of Concorde and thought, that's what I want to do, I want to be a Concorde pilot. And that came true too. So I started flying Concorde, and I was lucky enough to fly the airplane for 22 years. And they tell me I've got more supersonic hours than anybody else in the world. So I was just getting the hang of it when in 2003 it had to retire. That's a joke, by the way. But in that time, the airplane had developed, and it went through that period of time, and as 2003 approached, I was sad when I was chosen, but I was honored and privileged to be chosen to fly the very last scheduled flight from New York to London. And after that scheduled flight, my mind turned to the future. I always look forward, not back. A future where we could have the renaissance of supersonic travel, where we could have another supersonic aircraft, but this would be a modern one that had better fuel economics, had better ergonomics, had sustainable fuel, had the ability to fly greater distances, met modern Chapter 14 noise regulations. I was waiting for that moment, and 10 years ago I suddenly saw on the horizon an individual with the same vision. A visionary who could drive these things forward, a visionary who could make sure that he could gather around him the teams to deliver these sort of advances. And I'm very privileged to be close to this and watch it grow as it comes towards today. So, ladies and gentlemen, will you join me in welcoming the founder and CEO of Boom Supersonic, Blake Scholl.
Wow, thank you, Mike. Like everything about Concorde, that was inspiring. I never got to fly supersonic on Concorde. I was 22 years old when it retired, and I just couldn't afford a ticket. Of course, it was a marvelous technical accomplishment, but also the story of a journey started, but not yet finished. It came and went without changing how most of us travel. Indeed, that hasn't happened for 60 years since we first entered the jet age. And as we stand here at Farnborough in 2024, it's now been 2 decades since either Boeing or Airbus has launched an all-new airliner program. We're in danger of going a generation without any new airliners. So we've stopped progressing, and in many ways, we've gone backwards. It's never been more clear. Passengers and airliners are not well served by the duopoly we have today. And I believe that's important to do so all of us can travel faster, can travel better, can experience what it's like to live not just in our city, but on the planet. And to do that, we need supersonic flight. We need to do faster airplanes, develop faster. So today, it's all about speed. It's about accelerating the supersonic renaissance. And I've got some exciting updates to share with you about everything we're working on at Boom, about XB1, Overture, and Symphony. So let's get started with XB1. XB1, of course, is the airplane that sets the foundation for our Overture airliner. And it demonstrates some of the key technologies for a renaissance in speed, like digitally optimized aerodynamics, a carbon fiber composite airframe, and advanced supersonic engine intakes. And lastly, an augmented reality vision system for great runway visibility. XB1 is the first ever independently developed supersonic jet, and the first new civil supersonic airplane to fly since Concorde in 1969. As you know, in March, XB1 had its maiden voyage. And the most important goal on that first flight was to land safely. There were many firsts on that flight, but one of them was the first ever landing of a human-piloted airplane using an augmented reality vision system for runway visibility. Let's take a look.
Expect about 175 on file.
You're on, flight book. You're on center line.
Control test. Congrats to the whole XB1 team on a hard-earned victory.
So, happily, that first landing went great. And indeed, the first flight of XB1 ended with just 3 squawks. 2 were pretty trivial, and 1 notable item to address. We actually had better than forecast handling qualities on both pitch and yaw, but as our test pilot put it, roll is a little bit exciting. So to reduce pilot workload in the interest of safety, we decided to add a digital stability augmentation system for roll. And the team developed that in record time in just about 8 weeks. So today, I'm pleased to announce that we've finished installing the upgraded roll system on XB1. And as we speak in the Mojave Desert, it's a few hours before sunrise. The airplane is fueled, it's pre-flighted, and it's going to be back out on the runway today for one final taxi test with the roll stability system activated. And assuming today's test goes well, we're going to be back in the air for XB1 Flight 2 as soon as weather permits, most likely well within the next week. This keeps us on track to break the sound barrier later this year. And at that moment, XB1 will have become the first independently developed supersonic jet to fly faster than the speed of sound. And XB1 is foundational for Overture, not just in terms of the technology, but more important in terms of team and culture. I'm a big believer that small, focused, driven teams can do things the legacy players just can't or won't, and to do them faster and better. XB1 was designed and built with just 50 people, including engineers, technicians, and pilots. And we were able to do it about 10 times more capitally efficiently than any other supersonic program in history. XB1 has also established the foundation of our safety culture. And as I've worked to build this, I've come to believe that the most important thing for safety is how we as leaders show up when our team uncovers a problem. At Boom, we actively encourage every team member to surface problems when they find them and then work together to resolve them. So that's XB1, history's first independently developed supersonic jet, back in the air in the next few days, and on track to break the sound barrier later this year. So let's turn our attention from XB1 to Overture. And as you know, our ultimate goal is to accelerate flight for all passengers on all routes. But we're starting with Overture 1, which is an all-business class supersonic airliner for transoceanic flying at fares 75% lower than what it took to fly on Concorde. So imagine leaving Washington, D.C. and being here in London in less than 4 hours. Imagine crossing the Pacific from Tokyo to Seattle in just 4.5 hours, or going from Australia to Los Angeles in a remarkable 8.5 hours. Flights like these will change how we travel. They'll change where we do business. They can even change who we can fall in love with. While Overture, of course, is primarily for passengers, we're also working with the Air Force and with Northrop Grumman to bring the power of speed to the situations where time matters most. And while last time we did supersonic flight, it was a competition between nations. And we're proud at Boom that the team that is building Overture is truly international. A world-class team of suppliers and partners that are helping us design, develop, industrialize, and produce Overture. And airlines are excited. We've announced over 130 aircraft on order and pre-order for some of the world's best airlines, like United, American, and Japan Airlines. But we're just getting started. Each year, tens of millions of passengers fly in first class or business class on routes where Overture can fly faster and fly profitably. And to carry these passengers supersonic, airlines are going to need well over 1,000 Overture aircraft. When we talk to passengers, 97% are looking forward to supersonic flight. I think the other 3% clicked the wrong button. And remarkably, 87% would switch away from their preferred airline, walk away from their frequent flyer miles, and switch to a different airline to access supersonic flight. And what this means is that supersonic flight is going to provide a competitive advantage for early adopter airlines, something like we haven't seen since the dawn of the jet age. So all of this means we're going to need to build a lot of Overtures. In June, just last month, we opened the Overture Super Factory in Greensboro, North Carolina. Like I said, we're all about speed. It was 17 months from groundbreaking to opening the Super Factory. This is a 175,000 square foot facility on a 62-acre campus. That first final assembly line is designed to produce up to 33 aircraft per year. And we have space reserved on our campus to build at least 2 and possibly as many as 3 assembly lines in Greensboro, producing up to 100 Overture aircraft every year. And building this super factory, we actually had a perfect safety record until the day of ribbon cutting, when, yeah, I cut myself on the scissors. As CEO, I try not to make the safety slide, but I did this time. So let's talk about today's Overture news. 2 years ago, you got to see the production Overture design. And last year, we met the team of suppliers that are working with us to deliver Overture. So we've looked at the outside, and today, to take a step on the inside of the Overture experience, starting at the front of the airplane with the cockpit. So today, you get to see the Overture flight deck, the flying experience of the future. But before we take a look at the future, let's look backwards for a moment. So this was Concorde. So many switches, buttons, knobs, displays, controls. It took a flight deck of 3 to fly Overture safely, and pilots as amazing as Mike Bannister. And the last new airliner flight deck we had was actually the A320 flight deck introduced in the 1980s. And as you can tell, we did make some steps forward, but still, there were hundreds of knobs, switches, dials, controls. Lots of complexity to fly this airplane. So today, we're going to get to see a reinvention of the cockpit, and an all-new flight deck that I think is 5 years ahead of any other airplane flying. Let's take a look.
What we saw today in the flight deck was a level higher above what we're utilizing in Boeing and Airbus jets today.
This is a quantum leap of sorts to be able to have the fidelity to land the aircraft without looking outside at all.
I think all of that lends itself to extremely safe operation. This particular suite of avionics seemed to strike just the right balance for me.
The Overture flight deck is about a marriage of hardware and software, a union of pilot and machine. We've eliminated hundreds of fiddly physical controls, and we've built the flight deck around 4 large, gorgeous 17-inch touch displays. Every single function on the airplane is accessible through touch. You need to pull a circuit breaker in an emergency, you don't have to go hunting for it. It's right there on the screen. And Overture also has trackpad cursor control, meaning that even during turbulence, every key function will easily be accessible. We're also building in the most advanced flight controls. On today's flight decks, pilots have to choose between automation and having a tactile feel of how the airplane is flying. We think they should not have to make that choice. And to accomplish that, we've incorporated dual force feedback side sticks. You can actually feel how the airplane is flying. And you can also feel how your co-pilot is flying. Overture's fly-by-wire system sends artificial feel to the stick, giving pilots a tactile stick and rudder experience on top of the most advanced flight control system. The sticks move in tandem for exceptional situational awareness. And as we know, in emergencies, it's often easy for both pilots to reach for the controls at the same time and not know. These force feedback sticks give the pilots a visceral, tactile experience of what's going on, making them aware when this is happening. And lastly, the force feedback also connects pilot with autopilot. Overture's autopilot works like a third person on the flight deck, and the autopilot inputs drive the sticks as well. This allows the pilots to know exactly what the airplane is doing and to make a more seamless transition from automatic flight to manual flight. So next is landing. Concorde was famous for its drooped nose. It needed to be long and skinny for aerodynamic reasons, but in order to see the runway, it had to mechanically move out of the way. So what about landing on Overture? We actually expect most Overture landings to be automatic. we're building in the most advanced auto land for a buttery smooth landing that's gentle to pilots, to passengers, and to the airplane itself. But of course, pilots sometimes are also going to want to land manually. And so there are two different ways to do that. We're building on that augmented reality technology that we demonstrated on XB1 with two different augmented reality options for pilots. The first is an ability to see a camera view on the pilot's primary flight display, being able to look right through the nose and see the runway for landing, just as we did on XB1. But additionally, we're incorporating a head-worn display, so pilots can kind of look through the lenses and see outside the airplane, an experience like you'd find today on the F-35. All of these technologies build on a strong certification heritage, such as the 00 Enhanced Vision System landing capability found on today's most advanced business jets. So, lastly, as we said, today's flight decks are filled with myriad switches, buttons, and controls that are fixed in hardware and that can't change after the airplane is shipped. Because Overture is designed around software and touchscreens, we're able to deliver over-the-air upgrades, meaning new features and improvements can be delivered regularly. And of course, airlines are going to have full control over how software updates roll out across their fleets. So, to tell us more about what it's like to fly Overture, I'd like us to hear again from British Airways retired Chief Concorde Pilot Mike Bannister, who over the weekend became the first pilot to have flown Concorde and Overture. Let's roll the video.
My name's Mike Bannister, and I'm the former Chief Concorde Pilot at British Airways. The Overture flight deck is absolutely stunning. It looks beautiful, but it is so intuitive. And the first thing that struck me was, where's the control column? Because Concorde had a big control column in front of the pilots. Here, that's gone. It's a side stick. Now, I'm not familiar with a side stick, so I was slightly hesitant about how it might be, but it was just straightforward, intuitive, and natural. And the force feedback that you get was great. On Concorde, you could see the control column moving. On the Overture, you can actually feel it. The BAE side sticks are moving in tandem. Concorde was a beautiful airplane to fly, but with conventional instrumentation, it was complex. When anybody looks at the flight deck, the first thing they say to me is, however do you know what all those instruments do? The lovely thing about the Overture flight deck is the way it's laid out. It makes it so much simpler to gather the information into your brain, to process it and to action it. And you can do that together. The two pilots are working together, fully integrated. So it's lovely to have the ability to gather everything in whilst at the same time not be cluttered. One of the most distinctive features of Concorde is its movable nose and visor, which was put down for takeoff and more importantly for landing because Concorde came in so nose up. But with the Overture, that can be taken away. You don't need that heavy weight and all that mechanical equipment. It's replaced with synthetic vision, which gives you a beautiful view, but more information at the same time. In the periphery, I can see all the engine instrumentation, all the information I need. I have absolute confidence that it will be the best flight deck in the world.
Thank you, Mike. That flight deck, the simulator, is in our chalet here at the Farnborough Airshow. And that flight deck, of course, we're doing with some great partners working alongside us. Those head-worn displays are coming from Universal Avionics. The side sticks featured in the simulator here in Farnborough are from BAE Systems. And the entire system and those touchscreens are coming from Honeywell, where we're building on top of their latest generation Anthem suite of integrated flight deck and avionics. And to share more about our collaboration with Honeywell, I'd like to invite to the stage my good friend Jim Courier, CEO of Honeywell Aerospace. Jim.
Good morning, everyone. So I'm Jim Courier, the President and CEO of Honeywell Aerospace Technologies, and I'd like to thank Boom for having me here today. And I also like to thank all of the media that's in attendance. Blake Scholl and the Boom team have been a transformational force in this industry since beginning their journey nearly a decade ago. It's inspiring to see their vision and how it's become a reality, and I'm proud that Honeywell's Anthem's flight deck is along for this exciting ride. We share a vision of making supersonic commercial flight a reality again, but a way that is safer and more efficient than ever before. Renewed supersonic travel can truly pave the way to a future of aviation that connects the world like never before. With Honeywell Anthem aboard Overture, we're giving pilots a more intuitive cockpit that is more flexible and scalable. While working hand in hand with Boom, we are tailoring the Honeywell Anthem cockpit to meet very specific Overture's mission requirements. We're creating better situational awareness than ever before, and we're integrating cutting-edge safety features for pilots. At Honeywell, we care very deeply about safety of our products, and we're working on new ways for every element of flight and navigation to become safer and smarter. That has been our goal since day one, and we'll never waver from pushing for the safety enhancements we've become so well known for. We also set out to make the most user-friendly cockpit in history. It's completely cloud-connected while still being human-centric. It's inherently easier to aviate, navigate, and communicate with, and the pilots that fly the Overture aircraft will experience that firsthand. Our work with Boom reinforces our strong belief that the aviation industry is on the verge of a massive and positive changes. Along with Boom, we know how critical it is to make aviation fully sustainable, whether we're talking about urban air mobility or we're talking about supersonic travel across the ocean using sustainable aviation fuel. We both strive to grow this industry and one where supersonic flight is attainable for everyone. I'd like to thank Boom for having me here today, and again, thank you all for attending, and hope you have a wonderful show. In a few years, hopefully we'll be able to see the Overture taking off from a runway a couple of 100 yards away. So thank you, enjoy your day.
Thank you, Jim. You know, I'm reminded of when I first got to see the Honeywell Anthem deck a bit over a year ago. I flew myself from home in Denver to Phoenix, and a little airplane that I thought had nice avionics. And then after flying Anthem for the first time, on the way back, the avionics were just horrible. I can't wait for pilots to give this new flight deck a try. I think they're just absolutely going to love it. So, the Overture flight deck, built around pilots with safety at the forefront, incorporating touchscreen controls, everything in the airplane accessible via touch. Those force feedback side sticks, they keep the pilots connected to each other and to the airplane. You don't have to choose flying the airplane or automation. Autoland, plus an augmented reality vision system for manual takeoff and landing. And over-the-air software updates, this flight deck is going to keep getting better. So that's today's Overture update. Now let's turn our attention to the engine that powers Overture, Symphony, the first ever purpose-built engine for sustainable supersonic flight. 18 months ago, as you know, Symphony was really just an idea. And people asked us, why would we ever choose to develop our own engines? And the answer is that there are huge advantages in being able to customize an engine exactly for Overture's needs. But also, it enables us to move much faster in development. So today's Symphony update is all about speed. It's about speed of development, speed of testing, and speed of industrialization. Let's take a look. Isn't that cool? So our engineering philosophy is to design digitally, but then rapidly test in hardware, and plan to learn something along the way and iterate as we go. Small, focused engineering teams who build and test as they design are going to produce the best products fastest at the lowest cost. This is the magic that happens at the intersection of digital engineering and digital manufacturing. So today, 18 months from unveiling, we've completed the the Symphony concept design. We've built the first test parts. We've begun hardware rig testing. And I'm especially proud that we're throwing down the gauntlet today. We're going to have a full-scale Symphony core running on a test stand, producing thrust in just another 18 months by the end of next year. As an example of our rapid development approach, we started our first rig testing, the combustor rig test, just a few weeks ago. And those tests give us early learning, validating our computational methods, and allowing us to refine and optimize the design as we develop. We're building Symphony with a team of world-class suppliers. FTT, a unit of Kratos on the design side. Calibrium Additive helping us with additive manufacturing, and Standard Aero. And today we're also happy to welcome ATI to this team, who is supplying custom super alloys for Symphony that will give us reliable performance for extended periods of time at extreme temperatures. At full rate, as you know, we're going to be building 66 Overtures per year, possibly scaling to more. And we're starting to see other applications for Symphony for other commercial and perhaps military platforms beyond Overture. So we're going to need a lot of Symphony engines. And to build that many engines, we decided it was best to select a partner with deep experience manufacturing both commercial as well as military supersonic engines. It's a partner we already know well, Standard Aero. So today, I am proud to announce San Antonio, Texas, as the assembly site for Symphony, with over 100,000 square feet dedicated to Symphony assembly and test within Standard Aero's existing campus. So that's not a cartoon. That's actually how Symphony is going to be assembled. One of the benefits of working alongside Standard Aero as we develop Symphony is that we were designing the engine together with the manufacturing process, together with the maintenance process, which is going to allow this engine to go together easily and also to be easily maintained. So to tell us more about our collaboration with Standard Aero, I'd like to invite to the stage my good friend Russ Ford, Chairman and CEO of Standard Aero.
Good morning, everyone. As Blake said, I'm Russ Ford. I'm pleased to be here, and I want to thank Blake and the Boom team for allowing us to be a part of this historic collaboration. Standard Aero has been around since the beginnings of powered flight, more than 100 years. And on behalf of the thousands of employees that represent Standard Aero around the world, we couldn't be more excited about this aircraft and about the new technology that it introduces. Now, just among us, let's be honest, the engine is the coolest part of this airplane, okay? Because in supersonic flight, that's the most important thing. And at Standard Aero, we're all about speed and execution. And that's why I believe we are great partners for the team at Boom. Speaking for myself, I began my aerospace history almost to the day 55 years ago. It was on July 21st, 1969. And on that day, my parents allowed me as a young boy to stay up late, way past my bedtime, and watch Neil Armstrong step on the surface of the moon. That was the day I began my aerospace history. And it was a historic event. Little did my parents know the profound impact that would have on my life being dedicated to the aerospace industry. And let's make no mistake, what's going on here and what's going on with Blake and the Boom team is no less profound to what is going to happen in the future of flight. At Standard Aero, we began working with the Boom team several years ago, initially to introduce the ideas of maintainability in a sustainable supersonic aircraft engine. Over the last couple of years, we're now pleased to announce that we've expanded that partnership, and as Blake mentioned, we have dedicated a portion of one of our facilities. We have a 1 million square foot facility in San Antonio, Texas, along with heavy engine thrust test cells that will be dedicated to not only the assembly and test engines, but also to full-scale production. So we're really excited to be a part of this program. It is significant, it is history, and it's the future of flight. Thank you, Blake.
Thank you, Russ. So that's Symphony, the purpose-built engine for supersonic flight, built supersonically. We've built the first test parts. We've begun hardware testing. Over 30 hardware rig tests between now and certification. The first full-scale engine core running in 18 months by the end of next year. And then building a whole lot of Symphonies together with Standard Aero in San Antonio. Before I recap today's news, I'd like to take a moment to step back and just comment a bit about the state of the industry. In the first 55 years of aviation, we went from the Wright Flyer to the DC-3 to the Connie to the 707. And the speed of flight improved exponentially from just a few miles per hour to 80% of the speed of sound. But now it's been longer from the 707 to the present day than it was from the Wright Flyer to the 707. If we continued that trend in speed, we'd all be enjoying flights above Mach 5 by now. But instead, speed flatlined. And today's latest generation airliners are no faster than those that first carried us into the jet age. Indeed, as late as the 1990s, we did still develop airplanes and engines rapidly and efficiently. The 777 went from firm configuration to carrying passengers in just 5 years. And the GE90 went from a blank sheet of paper to certified in 36 months. And we could all trust that our airliners were built to the highest quality standards. But today, the legacy players are distracted. We all know the challenges facing Boeing, and Airbus is distracted with the opportunity to gain share. On the journey to faster speeds, we've lost 50 years. But our goal at Boom is to get humanity back on that speed-up curve and to give passengers and airlines the real alternative that they deserve. Overture 1 is just the start. We have plans for second and third generation supersonic aircraft that will enable high-speed flight over land and as well as expanded opportunity for all classes of passengers to experience the benefits of faster travel. Because when flights are faster, passengers can actually travel more, we will need more supersonic jets than subsonic, just as we needed more 707s than DC-3s. And as the market develops, I think we'll find that the market for supersonic flight is even bigger than the market for subsonic. So let's recap today's news, starting with a video. Thank you. So XB1, fueled, pre-flighted, headed the runway this morning as soon as we get first light in Mojave, and in the air again in about a week. Building the foundation for Overture, not just in terms of technology, but also in terms of safety culture. And Overture, reinventing the flying experience, starting for pilots with the first all-new airliner flight deck in decades, built around pilots with safety at the forefront. And Symphony, just 18 months ago, announced now into hardware testing and the first core running by the end of next year. And then building lots and lots of Symphonies with Standard Aero in San Antonio, Texas. Overall, we're remaining on track to deliver Overture ready for passengers just 5 years from now by the end of the decade. As I step back, there has never been a more important time for us to build a next-generation aircraft company, one that prioritizes safety while developing new airplanes quickly. Success has never been guaranteed, but I believe the risk is in staying at home and not trying. And I'm deeply grateful to everyone who has joined us on this journey, to our suppliers, to the FAA and EASA, to our customers, and of course to the team at Boom, and also to our fans and future passengers who are cheering us along. There are certainly daunting challenges left for us to overcome, but every day, more of those challenges are in the past. So thank you all very much for being here, and now I'm happy to take questions.
Hello? Yeah, good. Yeah. Hi, Blake. Over here, Guy Norris from Aviation Week. Thanks for the really in-depth update. What, if you look at the schedule, if you're running a core at the end of next year, as you hope, it's still a pretty sporty schedule, I think, to target the end of the decade for entry into service. What makes you think that you can do things really that perhaps other engine makers haven't been able to do in that time? And certainly, you know, what are the biggest obstacles, do you think, between now and certification? Thanks. Yeah,
Thank you, Guy. I think it helps to remember that we're not trying to do things any faster than they've been done before. I think that would be a mistake. We are benchmarking ourselves off of the best programs in recent memory. And those are really the 777 program in the 1990s, which delivered a high-quality, high-technology airplane literally to United on the day it was promised. And the GE90 engine went from a blank sheet of paper to certified in 36 months. So I think Symphonies actually take a little bit longer than the GE90. But from where we are today, we absolutely have the time that we need to execute this and to execute it well. And as I look forward to the future after Overture and Symphony, I mean, the reality is we've got tools that we didn't have in the 1990s. We've got much better automation. We've got better computer-aided design tools. computational fluid dynamics have come a long way. We've got additive manufacturing. The reality is we shouldn't be doing as fast as we did in the 1990s. We'd actually be going faster. So we're benchmarking for Overture 1 and for the first iteration of Symphony on the best that's been done in the past, which allows us to achieve the timelines we're talking about here. But as we look forward to Overture 2, Overture 3, we should be speeding up.
Timo Novak with Aero Telegraph. One quick question about the responsive side sticks, please. Will it be the same or a similar product that Gulfstream is using in its business jets, or is it something completely new?
I shouldn't comment on what is on other airplanes, but we are the sticks you see in the flight simulator. It's in our chalet here at Farnborough. Are from BAE, and we expect to go into production with a product that has the best possible, already high certification pedigree on it.
Hi. You said earlier that Overture is going to make flying better for all. Given the challenges for people with reduced mobility and also the increasing numbers of disabled people globally, what are you doing to make Overture accessible not only for passengers but also for disabled pilots returning to work?
I really appreciate the question, and yeah, we want to make supersonic flight available to everybody, and we'll have more to share in the coming years about the experience, not just for pilots but also through the rest of the airplane. At our headquarters in Denver, we have a full-scale mock-up of the passenger experience. We've been, one of the things I believe deeply is we have to design the inside of the airplane together with the outside of the airplane. We want engineers to think like designers and designers to think like engineers. And there are some real breakthroughs that we're not ready to talk about yet today, but I think will lead to just a really delightful experience from the moment you step on board, including for passengers with mobility restrictions. So that's something that we're thinking about. As just one example, we have a reduced mobility lavatory mock-up that we've already built and that we've made sure fits in the airplane.
So my name is Benjamin Cooper from Simple Flying. Congratulations on the new cockpit. It's truly revolutionary. But I think we have to think about also the issues with technology. Look at what happened a few days ago with the global IT outage. What is Boom doing together with Honeywell to make sure that whilst it is super connected, it is super safe? And are there any forms of backups in case the touchscreen doesn't work or switches off and the plane remains controllable and safe to land?
I really appreciate the question. So yes, we want the benefits of technology, and we want to be mindful of making sure we don't pick up risk along the way. So a few comments on the approach. I mean, first off, everything that goes in the flight deck is tested exhaustively, and we have over-the-air software upgrades that will have been tested before they get rolled out, that are delivered in a highly secure manner, and only after airlines have looked at them, tried it out with simulators, with their pilots, and said, great, we're ready for this to go. Sorry, was there a second part of that?
Yeah, about how you plan to respond if the touchscreens go down.
Oh, yes, thank you. Yes, so everything is accessible on the touchscreens, but we've made sure we've preserved a small number of physical controls that the pilots can access tactily for critical functions. And so above the touchscreens, for example, are the controls for the flight management computer, so you can select your heading, your altitude, your target airspeed, the throttles, the fire response controls. Those are all physical. You can close your eyes and find them and do exactly what you need to do. Additionally, there's redundancy built into every bit of avionics. There's redundancy built into the screens themselves, as well as the multiple screens across the flight deck.
Felipe Salles from Base Militar in Brazil. My question is, One of the things that I learned very early in covering the area of technology is that you don't want to mix a new aircraft with new engines. That would be a risky move forward. What exactly is needed for someone to offer engines that would work on the type of flights that you're going to be doing with Overture? Why does it have to be a new engine? And could you adapt existing engines to do this mission? There were proposals earlier, some 5 years ago, to use normal 727 engines, but equipped with different intakes that would allow you to achieve risk reduction, but that came and went.
Yeah, so why have purpose-built engines for Overture? Why not just take an existing engine and kind of shoehorn it in? Well, we rather famously, we looked at that. And what we found is that it could be done, but it came with some big drawbacks. And the most notable ones are reliability, efficiency of flight, and development time. And to elaborate on those, if we took a subsonic engine and put it in a supersonic airplane, what would happen is it would spend a lot more time at high temperature, at high stress than a typical subsonic engine would. A subsonic engine is really full throttle for just a few minutes at takeoff. And for most of cruise, it's throttled back, not running at its most thermally stressful point. But if you take that engine in a supersonic airplane, the profile is reduced. It's actually throttled back at takeoff, and it's full power at cruise, which means that engine is going to wear out pretty quickly, and it's going to need a lot more maintenance. And if you take that together with the legacy engine business model, where all of the money is made in spare parts, now we have a world where we have an engine that's going to need a lot of spare parts, and those spare parts are marked up like 4 or 5 times. And we looked at the proposals we had, and it literally 40% of the cost of flying supersonic was going to be engine spare parts. And we said, wait a minute, we can do better than this. We should design an engine for high reliability, and we should switch with a business model so that we're not soaking our customers when the engine breaks. And what that means for passengers, to put this in concrete terms, is with a Symphony engine versus an adapted engine, literally it's hundreds of dollars less per passenger to be able to benefit from supersonic flight. This is going to change very significantly the number of people who are going to be able to benefit from Overture. And then I think the other thing that's important to remember with respect to engine technology, this is a new design engine, but it's not a new technology engine. Turbofans have been around since the 1940s. And what we're doing here is customizing a turbofan to fit the needs of Overture. So we're turning up the cooling airflow in the turbine, for example, to help achieve longer engine life and higher part reliability. And we're turning down the pressure ratio because the intake does part of the work of the compression. So this is all stuff that's been done before. We're just turning the knobs and switches and dials and making them fit what Overture needs. And we're doing that because it's going to give passengers and airlines a huge benefit. Lower fares, more profitability on more routes, and longer time between the engine has to come off the wing for maintenance.
Good afternoon, still afternoon. Jose Suarez from Mexico en el Aire. Question, I see that you are designing an aircraft that you're thinking a lot of the pilots for the cabin, for the cockpit design. So what are your thoughts on the single pilot topic? Is this aircraft being certified for 2 pilots? And what do you think on the single pilot topic?
So we're designing Overture for 2 pilots, down from 3 on Concorde. And we think that that's the right way for Overture to enter service. Other people are talking about single pilot, other people talking about no pilots, and I don't think that's the right place for supersonic flight to start. So we're going to start out with 2 pilots in the flight deck.
I think we have time for one more question.
Hi, thank you. Charlotte Bailey, Aerospace Global News. You mentioned a survey there that said 97% of people were looking forward to flying supersonic, which I don't think anyone in this room, apart from 3% of you maybe, would disagree with. Given I'm assuming that the price point of a ticket on board this is going to be higher than your average conventional non-supersonic airliner, how many of these do you think will be a one-time only for the experience versus regular repeat customers? Thank you.
We want Overture to be the way that passengers get to fly over and over and over again. And to do that requires hitting a profitable price point that's in the band of what people are already planning to fly, and then marrying that with a flight experience on board that is the preferred way to travel. And of course, on Concorde, the fares were stratospheric, and the seats, we have a couple of Concorde seats in our office, and they were like, if you didn't know better, you'd think they came out of like a Ryanair 737. The one thing they have that we don't have on Overture is ashtrays. Yes. So Overture will be profitable for airlines at fares very similar to what passengers are already flying in business class today. And literally, that's tens of millions of passengers that are already flying in business class, already paying the same kind of fare that they would need to pay on Overture today. And that's Overture 1. And if we marry that with a great onboard experience, I think we're going to find that people not only switch their subsonic flying to supersonic, they actually fly more supersonic than they ever would today. Meetings that today we either wouldn't do or we do on Zoom, instead we'll be able to do in person. We'll be able to vacation in much further away places than we would today. I think all of that is going to have tremendous second-order effects, and what we'll find is there's actually more supersonic flying than subsonic flying. And then as we look forward to future generations of aircraft, what we're going to do is expand supersonic flying from transoceanic to everywhere, and we're going to expand it from business class to premium economy, and then we're going to go from premium economy to all passengers.
I think that's the last question.
All right, well, thank you all very much.